Okay, cool. Uh, Hello, everyone. Super happy to be back here again. I was very happy last year that Vue Fes Japan was able to restart, and also very happy to see even bigger crowds this year. So again, I would like to say thank you to all the organizers, sponsors, volunteers, and everyone working so hard to make this happen. Thank you. Today, I'm going to be talking about Vue, Vite, and the future of JavaScript tooling. All right. So the first half, well, let's take a look about Vue. So Vue is now 10 years old. Surprisingly, that's a very long time in front-end technology time spans. People joke about how there is a new framework every day in JavaScript, but Vue has been here for 10 years, and it's kept evolving. So I'm really proud of that, and so I want to take this opportunity to take a look at a brief overview of its timeline. So the first release with the name Vue.js was actually in 2013. It was still a side project when I was working at Google. But I worked on it on and off in my spare time until the first public announcement was in February 2014. So that was the official time when I first showed Vue.js to the world. And 1.0 was in October 2015 and 2.0 in October 2016. And also in 2016, I started working on Vue full-time as an independent developer. So the work on 3.0 started in September 2018. And 3.0 took a very long time to develop because at that time, the Vue has grown in terms of scope as a framework. There are a lot of different parts of the framework that we need to develop, not just Vue core. Right? So the work started in September 2018. And we did a soft launch in September 2020 that was Vue Core, the release of Vue Core 3.0. And then we eventually switched over to Vue 3 as the default in January 2022. So that's almost more than 2 years ago. And Vue 2 officially went end of life in December 2023. So I think the longevity of Vue and its continued growth is because it's a framework that keeps evolving, right? We are always thinking about how we can make Vue better. And also, it's based on how the JavaScript ecosystem has been changing over time. So in Vue 1, we used DOM-based templating, which means the template parsing and rendering of Vue 1 was coupled to the DOM. So it cannot do server-side rendering. So in Vue 2, one of the main things we wanted to do was to introduce virtual DOM and with the support for server-side rendering. Server-side rendering also unlocks meta frameworks like Nuxt.js, allows you to get better SEO, allows you to get faster first-page rendering. And in 3.0, it's probably the biggest change in the whole history of Vue.js, of course. The main thing is we introduced the new composition API. And along with better TypeScript support, so these two changes are kind of together to support larger scale applications. Because over time, in the beginning, Vue was mostly used for smaller to medium-sized projects. But over time, more and more Vue users are starting to build bigger applications. There are more enterprise usage. There are more ambitious apps being built with Vue. So we need to support that kind of usage, which is why in 3.0 we introduced composition API and TypeScript, better TypeScript support. We rewrote the whole framework in TypeScript, and also brought up the language requirement baseline to ES 2015 so that we can use new JavaScript features that's provided by the platform. And 3.0 also give us better architecture in terms of the compiler architecture so that we can do more compiler-based optimizations. So this compiler architecture also unlocks future work because we can reuse a lot of the compiler pipelines to do different compilation strategies like vapor mode. Okay, so Vue's current and future. A brief overlook of Vue today in numbers. So Vue 2 and Vue 3, the two repositories on GitHub combined, has more than 9,000 commits. We have made over 500 plus releases over the course of 10 years. We have over 2 million users worldwide, over 250,000 GitHub stars, and currently at 5.3 million weekly NPM downloads. So that's more than 20 million downloads a month. We also have over 1 billion monthly CDN requests on JS Deliver. So CDN usage is kind of unique for Vue because Vue is right now the only mainstream framework that can be used without a build step. You can load Vue from a CDN and you combine it with any backend technology that you use. Right? So the adoption barrier is still the lowest among all the mainstream frameworks. So some growth numbers, interestingly, despite it being 10 years old, we actually grew by 37% in the past year. So considering the absolute number and saturation of the market, this is actually quite impressive. And another stat to look at is the Vue 3 growth, right? So this graph is tracking the @Vue/runtime core package, which is a dependency in Vue 3. So we use this as a proxy to track Vue 3 growth. Actually almost doubled in the past year. So Vue 3 growth has seen significantly increased adoption since the end of life of Vue 2. So Vue 3 now constitutes more than 66% of total NPM usage. And this number keeps growing as time passes. So we do hope, so we know that a lot of applications, legacy applications staying on Vue 2 will probably stay on Vue 2 for a very long time. But we're also glad to see that most new applications being built today are using Vue 3. So after the Vue 3 release, we made some stable, so we want Vue 3 to stay stable. We want Vue 3 to be a stable foundation for you to build your applications for the next decade. Right? So we don't want to introduce any kind of big breaking changes or force you to rewrite your apps, which is why all the minor releases in Vue 3 are introducing either just features or development experience improvements. Right? So some of the most notable ones in 3.2 was script setup. In 3.3 was better TypeScript DX for script setup macros. And in 3.4, we started doing more of these rewrite the internals without forcing you to change anything. So same code, upgrade, and it just runs faster. Right? So for example, the parser rewrite. In 3.4, the parser becomes 2 times faster. We refactored the reactivity system to make things more efficient, and we introduce development experience improvements like define model. So the latest release that was actually just out last month was codenamed Tengen Toppa. And it includes even more reactivity efficiency improvements. Right? So the first notable change is it uses much less memory compared to previous versions. And it also improves the performance significantly when you track a large reactive array. For example, if you have an array of 10,000 items, the efficiency of the new reactivity system deals with that much better. We also stabilized a feature called reactive props to structure. So this improves the development experience when you are defining lots of props with default values and you also want to keep them reactive. Use template ref is a new way of getting a ref from a element or component in your template. Right? Previously, the usage did not come with type safety. You have to manually cast the ref into the type you want. So use template ref not only is a new API in core, but also has IDE and type checking support. So now when you use template ref, it automatically infers the type based on which element or component you use the ref on. So so you no longer have to manually get the type of the component, then cast it into the ref. And then there's SSL improvements. We shipped built-in lazy hydration. So this allows you to defer the hydration of an async component until a certain condition is met. For example, only hydrate this async component when the user scrolls it into Vue or when you mouse over it, right? This can be used to also build higher level features, for example, in Nuxt.js. And then use ID. This is also useful in server-side rendering apps. For example, in Nuxt, you can use ID to generate unique IDs for your form elements, and they will be the same between server and client. So there will no longer be hydration mismatches. Previously, Nuxt actually has a built-in use ID, but now that Vue Core provides it, Nuxt can directly use the use ID provided by Vue Core. And we also shipped a lot of defined custom element improvements. This feature allows you to write a Vue single file component and build it as a native custom element. So you can use that custom element in any application, not even Vue ones. You can use it in React apps or Angular apps. So this feature has existed since 3.2, but in 3.5, we took another look at it and improved a lot of aspects of it to make it even more usable. Okay, so alongside with these Vue Core improvements, we also have a lot of different improvements outside of Vue Core in the supporting tooling. For example, for IDE support, right? Volar shipped a new major version. Previously, there was a feature called takeover mode that you have to explicitly choose to use it in order to reduce memory and get better performance. Because supporting TypeScript inside Vue single file components is quite complicated, right? But in Vue Volar 2, the new hybrid mode allows the thing to just automatically work. So you no longer need to configure it to get the memory usage and performance improvements. We also have a new version of the DevTools, the browser extension. In fact, this new version of DevTools is not only usable as a browser extension, but can also be used as a Vite plugin. Or it can be used as standalone as an Electron app. So there are many different ways to use it. And this version is also written with Vue 3, comes with much better performance, and interesting new features. In fact, it just shipped a new feature just this week. So the timeline, performance timeline inspection is now in this new version as well. Vapor mode. So this is probably the biggest new sort of long-term effort that we've been working on. Shout out to Kevin and Little Sound for the continued work on this. The performance has improved so that now it is actually on par with Svelte, Svelte Classic. So the graph is a little small, but you can see that it is noticeably more performant than the virtual DOM version of Vue and very close to Solid, which is probably the most performant framework that you can think of. So our intention for Vapor mode is so that when you have really performance critical situations where, but you don't want to leave the Vue ecosystem, you can actually use the same syntax to just compile it differently to get a better performance. So this gives you the best of both worlds, essentially. And 3.6 planning, main thing in 3.6 want to do is to stabilize the suspense feature. If you've used Nuxt, you probably have seen the suspense is experimental warning a lot of times. So we want to stabilize that. And also there are more potential reactivity improvements. Johnson on our team has been working on a new signals library that is based on the benchmark, is right now the most performant implementation among all the signal implementations, and we're looking at the possibility of, again, integrating some of those improvements into Vue core. And we also want to introduce Vapor in Vue core as an experimental feature so that you can opt in at a component level to say, compile this component under Vapor mode. And we want to make that setup as streamlined as possible. So it's essentially upgrade to 3.6, and then you can now use the script Vapor tag in your SFCs. OK, so that's about Vue. Now let's talk about Vite. Vite growth, again, has not slowed down. In the past year, there is 120% growth over the past year. So now we're at 15 million plus weekly NPM downloads. In the State of JS survey, this is this is a 2023 survey, but the results was only released this year. So it's the latest edition of the State of JS survey. In the survey, Vite got the #1 most adopted, #1 highest retention, #2 highest interest, and also the most loved library overall. And Vite got the #3 most adopted, #2 highest retention, and #1 highest interest. So a lot of positive reception across the board for the Vite ecosystem. And we have an ever-growing, vast ecosystem that's building on top of it. Right? So there are many client-side frameworks choosing to use Vite as the default tooling. Right? A lot of new React apps, instead of create React app, they are now using Vite for single-page applications. Svelte, Solid, Preact, they all use Vite by default. And then there are meta frameworks like Astro, SvelteKit, Quick, and Redwood, Remix, Analog. So this covers like the React, Angular, Vue ecosystems and some of the smaller frameworks. And then we have tools like Vitest, Storybook, built on top of it. Laravel defaults to use Vite as their bundler. And then there's Playwright, which uses Vite for its component testing feature. So this ecosystem is growing, and we just had ViteConf online earlier this month, and all the videos are on YouTube. So if you haven't watched it, you should check them out. So a common theme has emerged is that Vite has become the shared infrastructure layer for the next generation of web applications. Right? So the only thing left out is probably Next.js. But every other framework you can think of right now is now built on top of Vite, pretty much. But Vite is also not perfect. When I first created Vite, it was an experiment. And there were a lot of compromises that I have to make because it was only me developing it really fast. So there are some problems that we want to solve, but haven't had the resources to solve. So one of the most fundamental problems of the Vite architecture is that it still relies on many different dependencies with overlapping duties or overlapping concerns. Right? So internally, Vite relies on esbuild, rollup, and optionally SWC for different tasks. So these tools all have overlapping capabilities. Like esbuild can do bundling, transforming, minification. Rollup can do bundling. SWC can do transforms. SWC does some transforms that esbuild doesn't do. Rollup does something that esbuild doesn't do. Right? So each of them has some features that we need, but they also do a lot of things that overlap. So the problem here is, first of all, sometimes we need to use esbuild because it's fast during development. But in production, we need to use rollup because it gives you better application bundling quality. So that results in inconsistencies in behavior. And then there's also pipeline inefficiency, because the same source code that you write gets processed by these different tools, which all have different parsers, different transform pipelines. So your code gets parsed, transformed, serialized back to JavaScript over and over again. It's very wasteful, very inefficient. So one thing we wanted to do to fix this in Vite is to build a new bundler ourselves, which is called Rolldown, right? We announced the work on Rolldown earlier in 2023, and we've been working on it for almost a year. But as we worked on Rolldown, right, we are thinking about the deeper problems. Rolldown also relies on parsers. It also relies on transformers, right? So when we were investigating what we should use, and we realized we want a consistent tool chain to handle all these different things. We want the parsing, transforming, minification all to be also bundling, right? All of these things should be handled by the same AST, the same system. And we realized one thing. The challenge Vite is facing is a reflection of the JavaScript ecosystem at large, right? It's not just Vite has these dependency problems. Every JavaScript project, a big JavaScript project today, probably use hundreds of dependencies. We use different dependencies for almost everything we do, like for testing, for linting, formatting, bundling. So each of those things nowadays, for example, ESLint has its own parser, Prettier has its own parser, Vite uses 3 different parsers internally. So when you build a JavaScript application today, you are unknowingly paying a lot of extra cost just because you're using all these different things. So if we want to actually eliminate these inefficiencies and inconsistencies, we need a unified toolchain, right? So this premise is pretty straightforward to understand, and it's interesting that it's only a problem for JavaScript because JavaScript grew from a very simple language into one that is the most used language in the world today, right? During that process, we came up with all these different tools to solve different problems. Unlike languages, for example, like Rust. Rust come with something called Cargo. Cargo handles everything for you out of the box, right? JavaScript does not have that. And why don't we have that? We should have something like that, right? So, so who's going to build it? So this is why I started a company called Vue.0. And our goal is to build a unified toolchain for JavaScript that pretty much feels like Cargo for JavaScript. And it should cover a lot of the things that, most of the common things you need for JavaScript development. And this is the big picture. So at the very bottom layer, we have OXC, which Borschen will talk about in more details later. But OXC is a language toolchain that includes, starts from the parser, includes a lot of semantic analysis, transformer, minifier, resolver, linter, formatter, all these lower level pieces. So linter and formatter are more like standalone tools, but everything here are more like lower level components that together forms a toolchain. And that supports Rolldown, which is the bundler that can bundle your code not just for browsers, but also for different runtime environments. Because one of the responsibilities of a bundler is to take your source code and convert it into something that can run in any environment you want. For example, Cloudflare workers or Winter CG compatible runtimes, right? As long as you write standard JavaScript, you can use the bundler to make it run more efficiently. And then Rolldown will support Vite. Vite supports Vitest, and both Vite and Vitest together support all these frameworks that we talked about earlier at the top of the ecosystem. Okay, so that is our vision. So how far have we come? So the progress we've built so far. OXC. Borchen started working on OXC early on, before we even founded the company. But so far, we have built the parser, the linter, the resolver. And the parser is 100% spec compliance, plus semantic analysis and control flow graph. Linter has more than 400 plus ESLint compatible rules, comes with a VS Code extension. The resolver is made to be Node.js compatible, and plus also support tsconfig paths, and is also fully customizable. Right now, we're focusing on finishing up the transformer, namely transforming TypeScript, transforming React.js, transforming a feature called Isolated Declarations DTS. So this is a relatively new feature in TypeScript that once you turn this on in tsconfig, we can then use OXC to take your TypeScript source files and emit DTS files, the definition files, without going through TypeScript itself. So it's extremely fast. So we'll show an example of using this feature for library building a bit later. Then we also have the minifier and the formatter, which are both in prototype states. Both are already working, but we just need to make them feature complete at a later stage. So one of the biggest highlights of OXC is, of course, the performance, right? So in our benchmarks, everything we've built so far is the fastest in its category. So if we compare to, so unfortunately we have to compare to SWC because it is the most widely used parser and toolchain that's also written in Rust, but we're consistently 3 to 4 times faster than SWC in the things we've tested. So the parser, linter, resolver, and the transformer are all faster. And not only is OXC faster, but it also uses less memory and has a much smaller package binary size. So one of the reasons we don't use SWC in Vite is because SWC's binary is very large. It's 37.5 megabytes. It's twice as large as Vite and all its dependencies included. But OXC, its transformer is only less than 2 megabytes, right? So even if we include all these other features, it's going to be still significantly smaller than SWC and Babel for that purpose, right? So even Babel, which is written in JavaScript, is actually pretty large when you download all the packages. OK, now for Rowdown, we've created, so Rowdown has been in the work for a while, and we finished the basic bundling and OXC integration, which means different from Rollup, which relies on everything as plugins. Rowdown comes with a lot of features built in. So it can do handle both CJS and ESM formats. It can do code splitting and transform TypeScript and JSX, resolve node modules, all just works out of the box without plugins. We've also already finished advanced features like tree shaking, and it's also 90% compatible with Rollup plugins. So if you have been using Vite plugins or Rollup plugins today, most likely it already works in Rowdown. It also comes with advanced chunk split options, which is something that Rollup we have enhanced on top of Rollup. So it's the chunk splitting control is a bit more advanced than Rollups. So you can have better control over how code splits. Right now, we are finishing up Rowdown to refactor it as a general purpose bundler. So Rollup is JS first, but Rowdown will have first-class support for CSS, HTML, and static assets. We are also integrating Rowdown into Vite as we speak. So there is a branch that we've been working on. We can already use it to build most of the starter projects for Vite. And we are aiming to pass more tests as we speak. I think this percentage probably is higher now at this point because we just passed a few tests that were asserting behavior that's not, it's not about the correctness, but just because the tests were written differently. So I think we're probably at like 90% for build tests passing too. So we expect to have a version of Vite that runs on Rowdown, probably either end of this year or early next year. So 1.0 beta requires us to stabilize a few more things in Rowdown. Mostly, we are working on wrapping up, comparing the behavior to ESBuild and Rollup, make sure we cover as many edge cases as possible. And because our end goal is to use Rowdown to replace both Rollup and ESBuild inside Vite. So the performance of Rowdown, again, obviously is the fastest among everything we've tested. So this is a very demanding case. We're bundling 19,000 modules. You probably won't ever have this many modules in your app, but we just want to test how fast it could be. And Rowdown actually, so this one doesn't involve any transform or plugins. It's mostly just React JSX because we do want to test the built-in transforms. So Rowdown completes the bundling in 0.6 seconds. Rowdown Vite is a bit slower because it does involve built-in plugins that's written in JavaScript. So there's a bit of overhead on top of raw Rowdown, which is pure Rust. And ESBuild, Farm, and RSBuild are the other bundlers that we are comparing against. So ESBuild is quite fast, but Rowdown can actually be faster. And Farm and RSBuild are other bundlers that are written also in Rust. So you can see, even though Rowdown and these other bundlers are all written in Rust, which is a very fast language, we can still be significantly faster. It's not like 20%. We're like 3 times faster than other Rust bundlers because we care about performance at a very low level. It all stems from at the parser, from OXC, the transformer, the resolver. Everything we do, we care about performance in every possible case. So one case study that we have here is when we are bundling Vue, right? So Vue is actually a pretty complicated project in terms of bundling because it's a monorepo with 11 packages. And for each package, we have to bundle different formats. We have to bundle CJS, ESM, ESM for browser, ESM for bundler. We also have to bundle global build, which runs directly in the browser, right? So in total, there are 62 different bundles we need to do in the Vue build pipeline. In Vue 3.2, we were using a setup that everything was written in JavaScript. Rollup, the plugin, the minifier, plus the DTS bundling, everything is written in JavaScript. The setup was also not very efficient. So when we were developing Vue 3.2, a whole build takes almost 2 minutes. So in 3.5, we started to move some of the things over to native tooling. For example, we replaced the TypeScript transform with ESBuild. We replaced the minifier with SWC. So these are all written in native languages, right? So this significantly increased the speed. We brought it down to 8.5 seconds. But in 3.5 experimental branch, we switched over from Rollup to Rowdown, which also handles the transform and minify via OXC itself directly. And then we use OXC transform and the isolated declarations feature to emit TypeScript definition files directly through a syntax transform without going through TypeScript itself. So this brings the whole build pipeline down to almost 1 second. And can be even faster in the future when we handle the DTS bundling directly in Rowdown itself. So it's just Rowdown directly without plugins to bundle the whole Vue build pipeline. So that'll probably be something around 600 to 700 milliseconds, right? So we've come a really long way because literally we can make it 200 times faster than the build speed when we had in Vue 3.2. Okay, so what's next? The most important thing about Vite is we are setting a long-term plan to slowly change Vite internally for the better, right? So this is Vite now. The most important thing that's in the upcoming version 6 of Vite, which is now in beta, is the environment API. This does not affect end users. If you are just using Vite for single-page applications or using it through a framework, right, you don't need to worry about this because this API is designed for frameworks built on top of Vite. But it will make their jobs easier. It will also make a lot of things more clean internally. So after environment API goes stable, the next stage is replacing these fragmented dependencies with the unified toolchain that we've built, i.e. OXC and Rowdown. So they will get inside Vite. And we plan to do this with minimal friction, which means if you have an application that's running on Vite today, it should just get faster without you having to do major migrations or anything. Right? We are just swapping the internals out to make things more efficient. And then, in a future version of Vite, so I should mention, like in this graph here, the upper parts that's in blue here is written in JavaScript, right? So there are a lot of things in Vite right now that's written in JavaScript. And then Rowdown sits at the bundler level. So it only handles the bundling and transforming responsibilities. But in the future version of Vite, we are going to slowly move a bit more things into the Rowdown side, into the Rust side. So what are the good things that should be moved into Rust? I think those are the things that are well-defined, slower moving targets, things we know is going to be very stable. We can port them over to Rust to make them more efficient and more consistent. And then we can reduce the dynamic parts in the JavaScript layer. But for end users, especially if you're using Vite via plugins or config files, the experience will remain exactly the same. So this will also not affect you if you are an end user. But this will allow us to make Vite internals even cleaner, even more efficient, and also solve a problem, which is the unbundled dev server. Because right now, when you use Vite, if you have, say, 5,000 modules that's unbundled, the page load can still get slow, right? So in this mode, we will offer a full bundle mode that allows you to still pre-bundle everything together so that your page load is only one request during development, while still retaining the ability for hot module replacement. So this is this mode is currently in prototype state, but we've run some benchmarks. So to get the fastest startup times and also fastest hot module replacement time among all the options that we know. So this is going to be coming as an option in a future version of Vite. So fundamentally, we want to solve every known issue, whether it's performance or consistency or long-term stability. We want Vite to be the best possible build tool for the next decade. Okay, so that's it. Thank you very much. And yeah, hope to see you get to use these new features very soon. Thank you.